Assalamualaikum warahmatullahi wabarakatuh. We are from Group 9 and our project is integrating landslide susceptibility mapping for disaster risk reduction. Before I proceed, let me introduce my group members. First is me, Muhammad Fahim, HARESHRAM, DAMIA, AMYRA, SHAFIKA and AIDA. Okay, for the introduction, this project performs an intermediate analysis that predicts SIREH Part Zone 1 landslide. It helps to assess and reduce SIREH Part landslide risk through calculating and displaying gentle foothills and steep slopes. Due to geology, topography and human activity, SIREH Part is prone to landslide despite its beauty and growth potential. Here, urbanization and infrastructure development require landslide vulnerability assessment and management. Weight of evidence, or WOE, was generated using geomorphological, hydrological and anthropogenic causal factor maps. Landslide Susceptibility Index, or LSI, computation created the landslide susceptibility map. So this is our study area, that is Zone 1 of SIREH Part. For the objective, we first to identify the predicted landslide area in Zone 1 of SIREH Part. Next, to improve landslide prevention in Zone 1 of SIREH Part. And lastly, to suggest potential solution for landslide emergencies.
So next, methodology. First, we need to process boundary on this Zone 1 because of the stakeholder opinion, and then spatial analysis process to each factor of landslide. We have 21 factors, so we need to process in spatial analysis tools. And next, after get the output of each factor, we need to weigh of evidence calculation from each landslide factor. After finish to calculate WOE, we will get the count for each factor, and then we need to calculate as landslide susceptibility index, which LSI, for final output.
This is the analyzing landslide susceptibility and land use, which is to show distribution and area percentage. So on this, we can see they have two analyses that we make. First is from the percentage of area for different landslide within classes. So from the very low to medium, which show the high percentage, which indicate to likely low likely landslide. For the second analysis, which is land use land cover area, that classified from the very high and high landslide susceptibility classes. So in this analysis, we can see that agriculture have the highest analysis, which is 19.2 for the very high and 1% in high classes. So this is mean that the area agriculture have more prone to landslide because of the area of itself is big, which is contain 80% of the area Zone 1.
For GIS applications and spatial analysis, there were four main factors that were used throughout the processing phase, which were geomorphological factor maps, geological factor maps, hydrotopographical factor maps, and anthropological factor maps. For geological factor maps, there were four factor maps, which were lithology, lineament density, and distance to lineament. For geomorphological factor maps, there were 8 factor maps that were used, which were geomorphology, slope gradient, slope aspect, slope curvature, stream power index, surface texture, terrain roughness index, and vector ruggedness measure.
Okay, next I'm going to explain about hydrotopographical factor maps. It consists of flow direction map, watershed map, flow accumulation map, stream network map, and distance to channel. Basically, this map is about water direction, how it flows and accumulates. The next is anthropogenic factor maps, which are distance to root, distance to water bodies, LULC map, and soil type map of SIREH Park. So basically it explains about land use and land cover. That's it.
Next this is the last part, which is the output of this landslide susceptibility, which we have from the legend from very low to very high. So as we can see from the very high, it shows that the very high steepness indicate to accurate more to landslide, which they have a very steep slope and geological surrounding. So when we go to the site visit, we can see that there is already a record for landslide, which is we can see they have gabier and more of water leak along the area. So in this legend, we can see that landslide inventory here is the landslide detection on this red area. So that's why this is prone to very high landslide.
Next for recommendation, first we have emergency preparedness, which is prepare a plan for landslide emergency, include safe evacuation routes and safety guidelines. Second, we have long-term planning, which is incorporate landslide risk into long-term planning for SIREH Park. So next is communication engagement, is conduct a campaign to educate visitors about landslide risk at SIREH Park. We have advanced monitoring system, which is utilize advanced monitoring system in SIREH Park for yearly detection of landslide risk.
The landslide project at SIREH Park presents an opportunity to enhance the safety, sustainability, and enjoyment of this natural recreational space. By implementing comprehensive risk assessment, stakeholder engagement, the project aims to reduce the risk of landslide and the potential impacts on infrastructure, visitors, and the environment. Then, ensuring the long-term success and resilience of SIREH Park.
Okay, I think that's all from us. But before we end this video, I would like to thank to our supervisor, Dr. Zulkarnain Rahman, for being patient and helpful to us. That's all from us. Thank you.